Hello everyone, greetings. Welcome to BIM Harambee Africa 2020. It's a wonderful experience to be part of this event. My name's Ahmad Mohammad Ahmad. I'm an assistant professor at Qatar University. First of all, I'd like to thank the committee for inviting me and giving me an opportunity to participate in this event. And my topic for the day is utilization of BIM models in a BIM-enabled project. Uh, BIM models are very vital to building information modeling because they can be seen as the core because most of the information are actually attached to the BIM models. So it is good to actually see what sort of challenges are faced by integration of these models into the entire BIM project. Okay, so enable to go through this project, my content would be an overview first of the project and then a problem statement. Then we'll show a methodology and how we did this and some findings that we came across. And at the end, to wrap this up, we will give some recommendations. Okay, so overview, basically the BIM models, where do they come from? They're basically an output of the design authoring process. The design authoring process itself, it's BIM use, and these BIM users are sometimes called model users, and at the same time, they can also be called BIM work streams. So they use interchangeably, and basically they are applicable during design, plan, design, construct, and operate phases based on Penn State University. And based on the BIM dictionary, these model users, they represent interactions between the user and the modeling system, which is used to generate some BIM-based deliverables. And these deliverables are so many, and some examples of them are clash detection, which is like one of the most famous BIM use, and then cost estimation, and so many other BIM uses. So before we go deep into it, also, these BIM uses can be categorized into two features where you have the purpose of the BIM use. The purpose could be maybe to gather or generate or do some analysis or to communicate or probably to realize something. And the characteristics of BIM models, one of the most interesting ones is that it's discipline based, could be certain disciplines conduct certain BIM uses, and some facility elements are used in these BIM users. Level of detail development, sorry, is also one of the characteristics of these. For example, when you do energy analysis, the LOD required is very, very low compared to something like record modeling, which is more detailed. You will also have the facility phase where you focus on what to actually achieve in the facility. Penn State further actually developed another BIM use version 2.10 where they actually try to break down the BIM users into primary BIM users and secondary. Primary BIM users can be basically something like cost estimation, phase planning, programming, site analysis, design authoring or MG analysis, 3D coordination. The other analysis that are seen as secondary are like mechanical analysis, lighting, structural analysis, and so on. But something to find interesting about this is that there is a link between these BIM users from stage to stage. For example, cost estimation is integrated from plan, design, construct, and operate. And another thing is that, for example, again, 3D coordination, it starts at the end of design phase and slightly goes into construction phase. But this was the first version, one of the versions that was done, version 2.2. Another version was actually done, version 3. And something to realize from here is that lots of changes and there's lots of development has happened. For example, coordinated design models, they usually occur at the end of design, but now they're occurring at the very, very early stages. So what does this mean? Okay, now this means that the person doing this model uses, if that means is someone has to carry it over. So if you have a traditional design where someone is doing coordination during design, that means there are some group of people that will still do the same coordination during construction. So that means you have to hand over some of those models to people who are not in your own discipline, which is one of the characteristics of the BIM use that we described by Penn State University. So this is just one of the main points to actually understand, that you will have to move these BIM users from different sections, from different stakeholders and designers, or even designer constructors as well. So the BIM users gives practitioners an opportunity to actually have some benefits, which it might be to analyze, to deliver, to optimize, and so on. But it does come with some challenges. So it is good to have an overview where we experience the whole package, where we understand the opportunities and the possible obstructions that take place. So to explore how these BIM models are utilized after they are developed, it's the whole idea of this project. So when they are developed, what happens? Now the BIM models are ready, and then what happens during the other facility settings? And this leads us into understanding what the problem statement is. So the problem that occurs is that the exchange of BIM models is challenging in the AEC industry. And as previously mentioned, these exchanges could happen from face to face, from practitioner to practitioner, from different disciplines. So two things were actually explored from this study. Within designated stages for the different BIM users, there are some exchanges that happen within different stages. And also there are some exchanges that happen between designers and contractors. But why is this a problem? So let's further want to find out. There's a diagram that was presented by Dawood, 2016. They noticed that whenever a stage ends, a drop point, there's always an information drop. So when you go to a stage that you have to exchange information is being lost. So this data loss actually causes some rework because this data is not available or is lost. So in order to reduce this waste, which is also cost energy, costs money, costs time, and at the outermost leads to data loss, can somehow be reduced. I wouldn't say it will resolve the entire problem, but it could be reduced. But in order to understand what is going to be reduced, I think we would have to understand what the gaps really are. So first is gaps emerge when you do this exchange at different stages of the BIM use, or with different practitioners, for example, designer and constructor. So when you have these gaps, you have to do some rework in order to jump the gap. Now this rework might cost loss of data, or cost of RFIs, and might take time, and might cause several other problems apart from data loss. So it's good to minimize or eliminate rework. So let's understand the nature of these gaps. So these gaps are broken down into two. So the first gap is it's created when conducting different BIM uses. So I'll give an example. Let's say we have BIM use number 1, which is design ordering. Okay. So now you want to do another BIM use, which is energy analysis, BIM use 2. Now, if you want to do energy analysis, you have to do some model adjustments somewhere here. And let's say after you do the energy analysis, you want to do some cost estimating as the BIM use 3, you would have to also do another model adjustment. And if you wanted to do another BIM use, probably 4D modeling, you might have to do another model adjustment. Now, these model adjustments can lead to rework as well. And another example that I would want to give, this is a massive research and study that people are conducting. Each one is a research of its own. For example, between design authoring and energy analysis, if the designer actually does the design, create the BIM models, forward them over to the energy modeler, the energy modeler sees the design and then wants to make some adjustments. He can't make the adjustments in Revit, so he would probably make the adjustments in, for example, IES, BEIES, or some other energy analysis software programs. So now, let's say he made an adjustment, and then it's not in the native Revit file. So now he has informed the architect that he has done some adjustments, which it's not compatible to Revit. So that means he did some adjustments, but the architect can't use it. So he has to look at the adjustments and then remodel in Revit and then resend to the energy modeler. So this is rework, back and forward. So this could lead to data loss, time wasting, more cost, and it's not efficient, not you at all. Okay, so technically, to summarize what gap 1 is, it's basically 4 different BIM uses takes place, and then you could have 3 possible BIM model rework and could lead to data loss. So each BIM use might require defined requirements during design authoring stage. So technically what we're trying to say here is like, why the gap? Why the rework? How does it come from? Where does it come from? Okay, so where the rework comes from is that for each BIM use, there are standardized requirements that have to be met in order to avoid doing the model adjustment. So where can these requirements be found? So these requirements are actually found in academic articles and industry reports, and technically there's a need for standardization and data availability. So it will be good if it is in one place where everyone can go find them, but they are scattered in different places. We made some effort to try and collect some data so that we can explain it. So this is a table where I have 3 columns. One is BIM use cases on the left-hand side. We have specific BIM use cases selected, some sources of data, and some requirements for the BIM use. So for example, energy analysis modeling, it will require a coordination view, it will require a space boundary in order for you to do the energy analysis. So this is the requirement for energy analysis. Where should it come from? It should come from the design authoring stage, the stage behind it. Okay, if it's not there, then they would have to do the adjustment. And when they do it, they want to send any additional information to the design authoring team. They can't do that because it's not compatible. So something that is also striking is that if you look at the sources, we have Building Smart, we have researchers, several researchers, we have COBIM, so they are institutional reports. They are also academic reports. So they're not in one place, they're all over the place. So if you can't find them and you have to go find them, then this makes the process very, very difficult. Another example that I want to give, I'm not going to go over the entire table. This is just to show you that there are requirements, they exist, and they are available all over the place. The example I wanted to show is for 4D planning. So for example, the way that some models are being done by the designer is different from how they're done by the constructor. The designer might probably just have some pipes and organize them in construction zone, and that's it. That's the designer's point of view. And for the contractor, he might put them into pipe sizes. So he might create a new layer and just put large piping zones and put them there. And for the designer, he might just put them in construction zone. So this creates a problem. So now if he got them from the designer and he doesn't want them like that, and then he has to do some adjustments as well. Okay, another thing, the model for facility management also, for example, they have to have some areas, they have to have spaces linked to services. If they're not linked with the services, they would have to do some rework. If space boundary is not included in the models, so they can't know the area, if they want to do painting or put carpeting or tiling to know the internal square meters to actually do some procurement for carpeting or tiling. So these are aspects that are very important for each specific BIM use. Okay, now going to gap 2. Okay, the second gap, what we actually came to realize was that these are due to model or information exchange between consultant and contractor. And this usually occurs during construction. And what this does is actually leads to remodeling. So once the designer finishes, he wants to take off, hand over the baton to the contractor. That's where the problem starts. So what is the problems? Before we get to the problems, we try to sum this up. Basically, gap 1 and 2 mainly identified or occur within a traditional construction. Because it's segmented, because there are no early involvement, and because the construction guidelines for legal purposes would not allow early intervention by other stakeholders, for example, the contractor's knowledge input. So before we get into this design contractor model, Skele 2016 detail showed that there are actually more than 2 models. We have as-built models, we have FM models, we have as-scheduled models. But for the purpose of this study, we're only going to look at design model and construction model. Okay, so let's understand first, what is the design model? Basically, it captures the intended design for project execution, design detail markups, and so on. And it shows quantity, size, shape, location, orientation, and so on. So what does the construction model do? The construction model usually represents a single building system, and it's created for the purpose of planning, scheduling, coordinating, fabricating components, and executing the construction. So it actually focuses on the construction phase. Okay, and another very important point to mention is design and construction models usually have different LODs. So it could be under the contract that the designer is supposed to present an LOD 300 design, usually in some places. And the contractor model is supposed to be around 300 to 400. Not all the time people are able to provide LOD 500, and we will tell you why in a couple of minutes. So it's very difficult to get to the highest level of detail, which is LOD 500. So the LOD levels are different between the different models. So this is an example. What we have on the left-hand side is a typical design model, and what we have on the right-hand side is a construction model. So the contractor model, actually, the difference, if you look very carefully, you'll realize that it's actually broken down into components that would allow the design to be actually built. If you look at the design model, it's built to mainly show design intent, but the contractor is more worried about how can he build it. Can he build this long wall? Probably no. He will build it in square meters, probably. So that's how he views the model. So the perception of the model is already different. So we would show another example again. This is also for the MEP. So the MEPs are designers as well. So MEP service remodel in red. So what you can see in red is the remodeling done by the contractor. What you see in gray is what is done by the designers, the MEP designers. So something to look at, you realize that the routing has greater detail in red, which if we go back to our point, the LOD for construction is more high. So it's given more detail compared to what the designer actually gave. So now if you look at this would technically show you the difference between the design and the contractor model. So you could see here that work is already been done. So here it's not actually a clash detection being occurred. It's mainly showing the rework that has to be done by the contractor because he doesn't see them as the way that they've been presented. So this technically what I'm trying to say here is this, it happens when you're doing the structure. It could also happen when you're even doing the MEP. So it happens in different places. So what method did we follow to try and mainly understand the main problems that actually occur? The methodology adopted was we actually did a couple of interviews with 6 participants, mainly all contractors, because the reason why we went for contractors was because we already have the design BIM models by the designers, and then they handed over, the baton is given to the contractor. So now we want to know what problems do the contractor have with the design models. Okay, so the people we spoke with are mainly contractors, some project managers, and some about 2 GCs, an average of 5 years experience. And this is mainly what we came to understand. We did a thematic analysis to analyze the data, and the findings that occur were that why does the contractors don't want to use the design models? So, and it's a contractor's perception. So the questions were more focused around this area, like what is wrong? Why don't they just use it? What is wrong with the models? And the contractor's perception, we found out 4 themes were identified. The first one, uh, some some of the participants mentioned that there's inaccuracy and inconsistencies in the models. So from the consultants, so or sometimes they're inaccurate quantities or construction errors in the model, so they have to just remodel it. And something that will shock you is how much percent of remodeling is usually done. We'll find that out in a couple of minutes. The second theme that we actually found out was the BIM use requirements. So each BIM use should have a specific modeling requirement, and one of the interviewer stated that each discipline, they build their models to meet their own specific requirements. So in many cases, the requirements of other disciplines are not considered, it's not their problem. So as a result, they will just have to remodel, and this leads to unnecessary rework. But something that they said was that they remodel, which may seem unnecessary to other people, but in a way, for them, it guarantees that the elements that they're remodeled meet their own specifications. So they're confident with the model. So regarding another third point is regarding communication. So the design model is used as a reference. However, it's been remodeled as a design model, communicate only the design intent. So they think that the model only communicate the design intent, but has nothing to do with how it's going to be constructed. So one of the participants mentioned that we just do not trust the models as limited constructors' knowledge is communicated during the design stages. So this may lead to inaccuracies. The fourth thing is the software technology issue. Software version compatibility is a major issue. So one of the interviewers said that the ideal method is to work continuously on the same model for better organization, but for the interoperability challenges, it is not possible. So sometimes, for example, someone mentioned that they used digital project to model the facade of a complex project for offsite fabrication. So for fabrication and installation purposes, the facade had over 1,000 unique parts, and the facade from the design model was not modeled into those required parts. Probably it had a very large part, and then it's left for the designers to go and find out how they're going to build it. So they have to use a certain software to do that. Probably they don't have the software to do that. Another issue is legal issues. So we categorize some under others. One of them is legal. So one of the also interviewers stated that there are some inflexible contracts that allow contractors to assist. Okay, they can assist during the design stage, but they are clearly state what they can and they cannot offer as advice due to liability. So they have to limit what they can offer. However, some contracts are flexible. So this liability issues becomes a barrier for early contractor input into the design and construction model. Another aspect of one of the other issues that we identified, coordination tolerance. So say that we have 5 or 6 different subcontractors. Now, one of the interviewers said that the tolerance standard used by a steel subcontractor may vary from that of a curtain wall window install. So if they put different tolerance, at the end, there is a possibility or chances of having problems because they view it differently. So there needs to be coordination on these coordination by subcontractors. Another issue of updating the design model. So you could have the design model, and let's say you even want to, you're happy that the design model is not well and you want to model it, happy to do remodeling. But the problem is, for example, someone mentioned, let's say that is a HVAC unit, which could be installed different. So they came to site and realized that they cannot install the HVAC the way it's actually been done. And they want to install it and then do the adjustment in the model. But unfortunately, the subcontractor cannot adjust the model. So he adjusted it, but he cannot adjust the design model. So now someone has to take part and do this adjustment. Another point around the contractor input is mentioned that because there's no contractor input, sometimes they have to go back to the designer saying that, for example, like, can you break a column into floors? Because sometimes a designer would create a column that is almost 20 or 30 meters long, just one long column. And they will say, like, could you break it into floors, or maybe break it into each floor so that they can use that to their benefit when they do the costing. So for example, the costing of the first 10 columns in the ground floor would be different from the costing of the columns in the next 10 floors. So the first 10 and the second 10 are costed differently. So if you create one large column by the design or trim team, then the contractor would have to break them. Now that would be a problem for the cost estimator, because now he can't use the model to do his cost estimation. If he's been told that he has to do cost estimation based on everything in the model, he cannot cost a 3 times 20, 60 meters long column for maybe 20 floors. Okay. So some other issues that we also came apart was the relevance of subcontractors. They need to be capable to model their parts. So each subcontractor needs to be able to do remodel or model his own part to a higher level of detail. So, but what happens if the subcontractor can do the work but can't do the modeling? Now the contractor would have to come in this place one interviewer mentioned that in this case, we might detail in 2D. So they will do a very good detail in 2D and they will simplify in 3D. Simplify means that they could just put a box or something else, and then the detail would be in 2D, so you won't find it in the model. Okay, another issue which I wanted to summarize everything. One of the interviewers stated that as far as they're concerned, 90%, 90% of the design of the model would have to be remodeled during construction. So they mentioned that they only use the design model for material procurement purposes. This is quite amazing. If you look at the amount of work that needs to be done, 90%, there's a high chances that you would lose data. Okay, so now what is our recommendation? Okay, so first recommendation we had was strategic planning. Okay, for example, through the EIR, BIM implementation plans or execution plans, model use requires and rules and requirements can all be described and integrated into these plans before the project even starts. And then at a later stage, maybe, or they can be inserted into the requirements into the EIR, which is the employer information requirement. Another thing is collaboration. The stakeholders need to collaborate very early, which I know it's very difficult when it comes to traditional construction. In some countries, the contractor is not allowed to be part of the design process. However, they should find a way to allow a neutral contractor to advise the design team to put some construction knowledge into developing their own model. The modeling requirements, as we previously mentioned, these requirements are everywhere. So they need to be standardized, made available, so they're easy to find and easy to use. So a single or network of models can be utilized from design to construction, but when all of these requirements are being stated or provided at the early stages. We had a diagram here. I'll try and explain this diagram as much as I can. So there are three rows here. The first row is the design authoring team. So in most cases, the modeling starts with the design authoring team. So the design authoring team is here, and then next we have information exchange in this row. So these are the information that have been exchanged. The next one, we have any other BIM model use or BIM use or model use or BIM work streams. They're all called the same thing. So let's, for example, when you start, you request specific BIM use requirements. So before anything starts, you should know how many BIM users do you want to use for this project of yours. So before anything starts, you can say, okay, I want energy analysis, I want clash detection, I want 4D modeling, and I want record modeling. Okay, then you can say, okay, can I send information to people who have done this before to tell me what are the requirements of energy modeling, 4D, and record modeling? So it's been sent out, and then they would actually forward the requirement to the design authoring team, parallel to the specific BIM. So they'll look at it, and then they'll send it back to the design authoring team and identify what is achievable and what is not achievable. So they will tell them these are the requirements, and after they told them their requirements, and the design team will look at the requirements and see, well, we can't do these, and we can do these ones. So they will adjust the model the best they can, and then they will prepare a feedback in this modeling rework report, and then they will send it to anyone who's going to be part of any other BIM use. And then they'll tell them what they can do and what they cannot do, and send what they have actually already been added. So now this means that anyone who is going to start this project will be able to make informed decisions. So before he even starts, he knows what he needs to do, because the design team can't do it. Design authoring team will not be able to do it. So this would reduce the RFI and would also allow more collaboration. So even if it was between designer and constructor, they could do the same process, get some information, know what they can add and what they cannot add. So people can be prepared for the project. So in a nutshell, these modeling requirements, they are exchanged prior to selected BIM users and inserted into the EIR. So once you have the documents, you know what the design authoring team can and cannot do, then you put only the ones that design authoring team can do. And then you put them as a requirement to design authoring, and you put the ones that the other BIM users have to do themselves. Maybe they have to do some small rework, but at least it has reduced the amount of rework. So we're not saying we're going to eliminate it entirely, but we're going to reduce it. So it's about reducing weights and being more lean. So this can actually be inserted into the ER and then can be shared with all relevant stakeholders at the early project stages, and they are able to make very informed decisions. So for more details, there's a paper called Investigating the Use of BIM Models for BIM Work Streams in Traditional Contracting. You would find some more relevant information there. And that's the end of the presentation. So thank you very much for listening.